Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Generative AI Beyond Text, an introduction to GANs and diffusion models. We've seen AI write stories. But what if AI could draw a new picture, compose a song, or even design a virtual world? That's what generative AI beyond text is all about. We're talking about AI models that create entirely new things that didn't exist before. Not just remixing existing data. Imagine giving AI a prompt like, a cat wearing a spacesuit on Mars, and it generates a stunning image. That's the magic we'll explore today. As a developer, you might wonder why this matters. Think about the incredible applications. For instance, in asterisk gaming, AI could generate unique characters or vast landscapes. In asterisk art and design, it can be a tool for artists to explore new styles or variations. Even in asterisk healthcare, it can create synthetic medical images for training other AI models. Protecting patient privacy, the possibilities are immense, and understanding these models opens up a whole new field for innovation. Our first powerful model type is generative adversarial networks. GANs. Think of it like a rivalry between two AI networks. 1. The generator. The artist. This AI's job is to create new data. Like a painting, it starts with random noise, like a blank canvas, and tries to transform it into something realistic, like a human face. 2. The discriminator. The art critic. This AI's job is to look at a piece of art and decide if it's real from a real dataset or fake, created by the generator. They train together. The generator tries to fool the discriminator, and the discriminator gets better at spotting fakes. This adversarial competition pushes both to improve, resulting in incredibly realistic generated content. So, what can a GAN actually do in the real world? Realistic faces. Asterisk you can generate endless unique human faces that don't belong to any real person. Style transfer. Asterisk take a photo of yourself and make it look like a painting by Van Gogh. Image to image translation. Asterisk turn a satellite image into a street map, or a simple sketch into a detailed photo. As a developer, you might use pre-trained GAN models as a component in your applications. For instance, to enhance images, create data augmentations for other models, or even prototype designs for virtual assets. The key is understanding their training data, what they learned from, as this defines what they can generate. Diffusion models are a newer, incredibly powerful approach. Instead of a contest, think of them as an artist who cleans up a blurry, noisy picture step by step. 1. The noise process. Forward. Asterisk we start with a perfectly clear image, e.g., a photo of a cat. We then gradually add noise to it, step by step, until it's just pure static, like an old TV screen. 2. The denoising process. Reverse. The diffusion model learns to reverse this process. Given a noisy image, it learns to predict and remove the noise, making the image slightly clearer. It does this over many steps, gradually transforming pure static into a coherent, realistic image. This step-by-step refinement allows for incredibly detailed and diverse creations, often surpassing GANs in quality for many tasks. Diffusion models are behind some of the most viral and impressive AI art generators you've seen, like DALL-E, Stable Diffusion, and Midjourney. Text-to-image. Asterisk describe anything. A cyberpunk city in the rain, painted by a Renaissance artist, and get a stunning image. Image in painting. Asterisk remove an object from a photo, and the AI fills in the blank realistically. Image outpainting. Asterisk extend an image beyond its original borders, creating new background to match. For developers, working with these models often involves using APIs. Application programming interfaces. To send text prompts or images and receive generated content. Understanding how to craft effective prompts, known as prompt engineering, is a valuable skill here. So, which one is better? It depends entirely on your project. GANs * often faster for generating specific types of data once trained, especially if you need consistent, high-fidelity outputs like realistic faces. However, they can be trickier to train stably. Diffusion models * generally produce higher quality, more diverse, and incredibly creative results, especially for text-to-image tasks. They are also more stable to train and easier to control with prompts. The trade-off is that they can be slower to generate images due to their iterative denoising nature. As a developer, consider, what do you need to generate? How important is diversity versus generation speed? How much control do you need over the output? This helps you pick the right model architecture or pre-trained solution. You've now been introduced to two powerful families of generative AI models. This is just the beginning of what's possible. Explore tools. * experiment with online text-to-image generators like Stable Diffusion or Midjourney to see the magic firsthand. Learn more. * if you're curious about the how behind these models. Dive into the basics of neural networks and deep learning. Code along. * look for tutorials on using popular libraries like PyTorch or TensorFlow to implement simple, generative models yourself. The field of generative AI is exploding with potential. And with your developer mindset, you're perfectly positioned to innovate and create amazing things with these tools. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.